express 2x square minus 8x plus 14 in the form 2 of x minus 2 the whole square plus b. So it is given 2 of. So let's take out 2 commonly outside. We get x square minus 4x plus 7. It is the completing the square format. Now see what is the coefficient of x. Here the coefficient of x is minus 4. Minus 4 divided by 2 gives 2. So the given expression can be written as x minus 2 the whole square minus 2 square and plus 7, which is nothing but 2 of x minus 2 the whole square minus 2 square is minus 4 plus 7 gives plus 3. So this is the required expression, x minus 2 the whole square plus 3. The functions f and g are defined by f of x equal to x square and g of x equal to 2x square minus 8x plus 14. Describe fully a sequence of transformations that maps the graph y is equal to f of x onto the graph of y is equal to g of x, making clear the order in which the transformations are applied. So f of x becomes g of x. And from our previous answer, we get 2 of x minus 2 the whole square plus 3. So x square becomes 2 of x minus 2 the whole square plus 3. This minus 2 and this 3 is the translation vector. So the first transformation is translation. And the translation vector is minus 2 can be written as 2 and 3 is written as 3. So the translation vector is 2 over 3. Next, it is multiplied by 2. So the second transformation is the stretching. And this is a vertical stretching. That is a stretching along the y-axis, and the stretching factor is vertical stretching with stretch factor x equal to x square minus 2x plus 5. A sequence of transformation is applied in the following order to the graph y is equal to f of x to give the graph of y is equal to g of x. Stretch parallel to the x-axis with a scale factor of reflection in the y-axis. Stretch parallel to the y-axis, the scale factor 3. Find g of x, giving your answer in the form ax square plus bx plus c, where a, b and c are constants. First, let us write f of x as x square minus 2x plus 5. So this can be written as x square minus 2x plus 1 plus 4. So that we can write this as x minus 1 the whole square plus 4. That is the completing the square. Now it's given stretch parallel to the x-axis. So stretch parallel to the x-axis with a scaling factor 1 over 2. That means x will become 2x. So this equation x minus 1 the whole square will become 2x minus 1 the whole square plus 4. So after applying the stretching, the equation will become like this. Reflection in the y-axis. So reflection in the y-axis means x will become minus x. So now replace x by minus x. So you'll get minus 2x minus 1 the whole square plus 4. Then the third one is stretch parallel to the y-axis with scaling factor 3. So again it's a stretching and the scaling factor is 3. So the entire equation will be multiplied by 3. 2x minus 1 the whole square plus 4. So this can be written as 3 4x square plus 4x plus 1 plus 4. Now multiply by 3. 3 multiplied by 4 is 12x square plus 12x. 1 plus 4 will be 5. 5 multiplied by 3 is 15. So g of x equal to 12x square plus 12x plus 15. The next question is question number 8. The curve y is equal to sin x is transformed to the curve y is equal to 4 sine of 1 over 2x minus 30 degree. Describe fully a sequence of transformations that have been combined, making clear the order in which the transformations are applied. In this question, a sequence of transformation is given. The sequence of transformation, if both are vertical or both are horizontal, then we have to take care about the sequence in which the transformation is taking place. If one is horizontal, another is vertical, or one is vertical and another is horizontal, then we need not worry about the order of the transformation. But here, first, let us consider the thing given inside the bracket. So we can say these are horizontal transformations. two horizontal transformations are given here. So first we have to do the transformation from right to left. For horizontal transformation, if both transformations are horizontal, so first we have to perform the thing which is on the right side. So it is minus 30, that is the translation. So that is the thing we have to, that is the transformation we have to do first. So we will say translation, and the translation vector is, so minus a, here the value given is minus 30, so minus of minus will become plus, so we'll write 30 degree and this is 0. And next is of multiplied by x, that is the stretching one, stretching transformation. With the stretching factor 2, and this is the horizontal transformation, so it is a factor of 2, it gets stretched along the x direction. So next is the number 4, and that is also stretching. And the stretching factor is 4 here, and this is a vertical transformation and it happens along the y direction. Then question number 2 is, the diagram shows part of the curve with equation y is equal to p sine q theta plus r, where p, q and r are constants. State the value of p. So in the given equation, y is equal to p multiplied by sine q theta. P and q both are stretching factors. The first question is find the value of p. So P is a stretching factor along the y-axis. So let us see how much it got stretched. So here it's 1 and here it is minus 5. So the difference between 1 and minus 5 is 6, and 6 divided by 2 is 3. So it got stretched by a factor of 3. The p value is 3. And next we have to find the q value. Q is again a stretching factor and it is stretched along the x-axis, that is it's parallel to the x-axis. Q value is, the diagram, the curve changes from 0 to 4 pi. In general, the sine curve goes from 0 to 2 pi, but here it goes from 0 to 4 pi. That is, it is expanded by 2. And when writing the value of Q, the stretching factor is 2 and Q value will be 1 over the stretching factor, which is nothing but 1 over 2. So the value of q is 1 over 2. Then we have to find the value of r, which is nothing but a translation. Generally, the sine wave starts from 0 to 2 pi. But in this diagram, we can see it shifted from, instead of 0, it shifted from 0 to -2. That is 2 steps. And the 2 downwards. So we have to write the translation factor r as -2. Next, question number 4. The curve with equation y is equal to x square plus 2x minus 5 is translated by -1 and 3 by the vector -1, 3. Find the equation of the translated curve, giving your answer in the form y is equal to ax square plus bx plus c. So the curve is y is equal to x square plus 2x minus 5. It is translated along the x-axis by -1. So it can be written as x plus 1 the whole square plus 2x plus 1 minus 5, then along y by 3. So plus 3. So x plus 1 the whole square. Let us expand this. X square plus 2x plus 1 plus 2 multiplied by x is 2x. 2 multiplied by 1 is 2 minus 5 plus 3. X square plus 4x plus 1 plus 2 is 3. 3 minus 5 is -3. Negative. So y is equal to x square plus 4x plus 1. The next part is the curve with equation y is equal to x square plus 2x minus 5 is transformed to a curve with equation y is equal to 4x square plus 4x minus 5. Describe fully that single transformation that has been applied. First, let us write the equation y is equal to 4x square plus 4x minus 5. We'll take out 4 commonly. X square plus x. To complete the square, let us find the coefficient of x. In this case, it is 1. That should be divided by 2. So 4 of x plus 1 over 2 the whole square minus 1 over 2 the whole square minus 5. So 4 of x plus 1 over 2 the whole square minus 4 multiplied by 1 over 4, you will get -1, -5. So this can be written as 2x plus 1 square divided by 4 minus 6. So this 4 and 4 get cancelled. So y is equal to 2x plus 1 the whole square minus 6. So it's given. So let us write this. Y is equal to x square plus 2x minus 5. So complete the square. X plus 2 divided by 2 is 1. So 1 square minus 1 square minus 5. That is x plus 1 the whole square minus 6. This curve has been transformed into y is equal to 2x plus 1 the whole square minus 6. So by comparing, we can see there is a only difference in the coefficient of x only. All other are same. So we can say it's a horizontal stretch of a factor 1 over 2. It is a horizontal stretch of factor 1 over 2. The function f and g both are defined for to r and are given by f of x equal to x squared minus 4x plus 9, g of x equal to 2x squared plus 4x plus 12. Express f of x in the form of x minus a the whole square plus b, that is completing the square, and f of x equal to x square minus 4x plus 9. The coefficient of x is negative 4. Negative 4 divided by 2 is negative 2. So x minus 2 the whole square, and subtract the 2 square value. So minus 2 square plus 9. So it is x minus 2 the whole square. Minus 2 square is minus 4 plus 9 is plus 5. Express g of x in the form. So again for g of x also we have to complete the square. 2x square plus 4x. 2x square plus 4x plus 12. So for the in the answer we want 2 completely outside of all the terms. So we will take 2 outside of all the term. X square plus 2x plus 6. Now we have to complete the square. The coefficient of x is 2. So we will write it as x plus 1 the whole square minus 1 square plus 6. So 2 multiplied by x plus 1 the whole square minus 1 plus 6 is plus 5. Let's express g of x in the form k multiplied by f of x plus h, where k and h are integers. So we have to express in the form of f of x plus h. So first let us write what is g of x. G of x equal to 2 multiplied by x plus 1 the whole square plus 5. And f of x is x minus 2 the whole square plus 5. Now compare both. We see there is a difference in the inside the bracket. So in order to write g of x in the form of f of x plus h. Let's rearrange this one. X plus 1. This plus 1 can be written as minus 2 plus 3, because minus 2 is in the f of x, so we are writing x minus 2, and but actual value is 1 plus 1, we have to get that, so minus 2 plus 3 the whole square plus 5. This is g of x now. So by comparing with the f of x, this can be written as, so here only the 3 got added, so we will write this as f of x plus 3, or you can leave this bracket also. So 2 multiplied by f of x plus 3. So g of x equal to 2 f of x plus 3 is the answer, where k is 2 and h is 3. The next part is describe fully the two transformations that have been combined to transform the graph y is equal to f of x to the graph y is equal to g of x. So y equal to f of x became y is equal to g of x, that is 2 multiplied by f of x plus 3. So f of x became 2 multiplied by f of x plus 3. So by comparing these two, we know, so there is a multiplication factor here, so it is a stretching. So there is a stretching happened, so it is stretched parallel to the y-axis with stretching with a stretching factor of 2. So next, if you compare the f of x and f of x plus 3, so plus 3 has been added, that is that it got translated and translated along the x-axis with the translation vector minus 3, 0. So translated parallel to x-axis with translation vector negative 3, 0. Next, the graph with the equation y is equal to f of x is transformed to the graph with equation y is equal to g of x by a stretch in the x direction with the factor 0.5 followed by the translation of the vector 0, 1. The diagram below shows the graph of y is equal to f of x. On the diagram, sketch the graph of y is equal to g of x. So let's draw the diagram. First transformation is the stretching in the x direction with a factor of 0.5. So let us mark that one. So this is 0. We'll start with 0. And this 2, when x is 2 and stretched by the factor of 0.05, so you will get, it will get become 1, and the next point x equal to 4 will become 2. So you will get these 3 points like this, and the top point corresponding to x equal to 1, it will become x equal to 0.5, and this is 3 will become 1.5. So you will get these points after applying the stretching. So followed by that, you need to apply the translation. So after applying the translation, let's see how the point gets translated. 0 and 1 is the vector. So the 1 indicates it's going to be transferred or translated or shifted along the along the y-axis. So parallel to the y-axis. So this point is along the y-axis is 1. It will be shifted one step upwards because it is a positive sign. So this will move to here. Similarly, all these 3 points will move one step up, and if you consider these 2 points, it will also move one step upwards. So now we transformed, just join all the points. So this is the g of x. Next B part is find an expression for g of x in terms of f of x. So first what we did is the stretching in the x direction with the factor 0.5. So g of x can be written as f of 2x. So 0.5 is the factor. It can be written as 1 over 2. So you'll write the 2 is the coefficient of x here. So we will write f of 2x. And next we are doing a translation, and along the y-axis, so it is plus 1. The diagram shows a curve which has a maximum point at 8, 12 and a minimum point at 8, 0. The curve is the result of applying a combination of two transformations to a circle. The first transformation applied is a translation of 7, -3. The second transformation applied is a stretch in the y direction. The question A part is state the scale factor of the stretch. So you have to find the scale factor here, and it's mentioned the transformation applied is a stretch in the y direction. If you apply a stretch in the y direction, there will be no change in the x-axis value, only y-axis value will get changed. And it's mentioned it is a circle, so there will be no change in the x-axis. So this will be the diameter of the circle. So the radius is 2. Radius of the circle is 2. Now let us see how much it got stretched along the y direction. So this is one circle, one stretch. This is 2 and this is 3. So totally it got stretched by 3 times. So the stretch scaling factor is 3. State the radius of the original circle. So we found already the radius of the original circle is 2. 2 units. State the coordinates of the center of the circle after the translation has been completed but before the stitch is applied. So you have to find the coordinate of the center of the circle after the translation before the stitching. So before the stitching means it is stitching applied only along the y direction. So 3 steps if you go down you will get it, because this is the first stitch, this is the second stitch. So this part is the original part and we know the radius is 2. So the circle must be in this part. So this will be the center of the circle. So the coordinate is 8, 2. The next part is state the coordinates of the center of the original circle. So center of the original circle means before applying the translation also. So the translation is 7 minus 3. Translation vector is 7 minus 3. And after applying the stitch, before applying the stitch, it is at this point 8, 2. So from 8, 2, from 8 we have to subtract 7 to get the original x-axis position value, which is equal to 1. So from 2 you have to subtract minus 3. So the original value will be 5. So the original circle, coordinate of the center of the original circle is 1, 5. So this will be the original value.